Hello guys, today I'm gonna show you how to solve the Can You Crack Me challenge on Fox in the Box. This is for the late April giveaway, and yeah, we're gonna go through the challenge and I'll show you my process in solving it. So basically, first things first, what you gotta do is you gotta get the challenge files. It's just a download. I already did that, so I don't need to do it. Then we're gonna open a terminal up. I'm using fish shell right here. You can see the path, fish shell with starship. Starship is like a prompt for your shell, and the shell is fish. If you don't know anything about that, you can research it. If you do, that's perfect. You also see Python here because it detected some Python files. I already wrote like a write-up stuff, which I'm gonna orient on, but I basically created these on demand. So what we have is we have the two binaries here. I'm gonna be working only with the Linux binary. If you want a Windows binary write-up as well, please tell me in the comments. So first things first is we check what kind of file this binary is. Linux has a command for that and it's called file, and we can see, okay, it's an ELF 64-bit LSB shared object binary, and it's not stripped, means there's still debug info in the binary. Second thing we do is we check for some strings in the binary. We can just call strings and then the name of the binary, and I like to pipe it into less so it's easier to look through. We know the format of the flag needs to be FITB, so we can just search for that, and we see some interesting things here, but let's get to that later. Next thing is we run the binary so we can see what it does, and we can understand later better what's going on. So if we start the binary, it's gonna ask us for a flag, and I'm just gonna input ape here, and it says starting check, and then it outputs like some messages. We can do this again with like a different input test. And we can see, okay, the output is changing, and it seems to do this somehow randomly, or maybe with the startup time, we don't know. Next thing is, we're gonna put our binary into a disassembler. I'm using Radara here, which you can just run with R2, but you can also use Ghidra, IDA, or some others. Radara is just, for me, most convenient and very simple to use. So yeah, we have put our binary, we have loaded our binary, and we've analyzed all stuff we need. That's basically always how you do things in Radara. You just analyze it, and now we can list all functions. We do this with AF list. If you don't know a command, you can just do question mark, and we see, okay, A analysis command, A question mark AF analyze functions, AFL list functions. Okay, I'm just gonna AFL here, and we see a lot of functions. So what we want to do is we want to take AFL, and in Radara we can still use shell commands like grep, and we can grep for a main function. So we see, okay, we have two main functions, one very weird looking one and a second one. We're just gonna seek into the main function down there, and then we're gonna enter the visual mode, and pressing Shift V, we're gonna enter the graph mode. So in the graph mode we can see, okay, the main function basically consists of this here, and it's just starting up, and then it's calling this other function here. So that's the other function we've seen earlier, so let's go to that one. Zim. So now we're at this function. I'm gonna enter the visual mode again, and we're gonna zoom out so we get like a blank feeling of what this function is. That looks very intimidating, but don't get scared yet. It's actually pretty easy once you understand it. So let's zoom in and kinda look through the code and see what's going on. We are loading some strings here, And we can see right here, that's what it's loading here. It's basically loading a lot of information and all the strings in the binary with that one, and it's putting that into memory. Yeah, then it's calling a standard out right here, and it's basically putting out this flag. So it's taking just the first six characters of this long string, and that's the flag thingy. That's why it's standing in the front there, and it's outputting that. So after we enter our stuff, we continue on here, and if we enter something wrong, we get here and we get immediately pulled down to this error handler right here. But we don't need that. I'm just gonna do a small trick to get back up. We just want to see what happens, what we need to do to get to the right end. Yeah, we're moving more down, and there's a lot of stuff going on. It's checking something. It's doing a lot of things here. We don't really know. We have some kinds of threading going on here or something. We see there's some errors being here told here, handle alloc error, and here we see a lot of strings, always with like different offset, we could say. So it's loading all the different answers here, and I think it's choosing, yeah, it's choosing something here. Moving down. 1 second. Okay, here we found something interesting. It's basically a loop. If we fail here, we're basically getting back up. So this could do something that we later need, so we're gonna remember that. We have some other interesting things going on here, because we're calling some base 64 stuff. And then we have a very interesting looking string here. Everybody who does something in cybersecurity immediately realizes, okay, this is base 64, and since we're calling something here, encoding it, I guess whatever we do earlier is getting compared. So first thing we could do is just copy that and put it into a website or base 64 decoder. So I'm actually going to do this right now. It's at the offset 0x6888. So I can seek to that address 068 0A PDF. Yep. PDF. We're gonna print all the lines, look a bit up, and here is the string. Gonna copy that and echo that and put that into a file. Let's call it enc b64 flag.txt, and let's take this file enc b64 flag.txt and pipe that into base 64 decode. No idea what happened here. And we get not a flag, so that's not it. So yeah, if we look further down, there's just some checks going on, and there's something printed as well. We have some output going on here. Looks like we're basically done, and we can start analyzing what's going on now. Okay, I like to handle these kind of programs by writing down what actually is going on. So we start with an input, and I will just put that there. And then from the input, we're going further into the program. So if we remember, we saw some other flags. And if you look through that, you can actually see like a flag FITB, never gonna give you up. And we saw another one, FITB. This could have been the flag, but it's actually not. In the beginning, our program kind of checks for this one, never gonna give you up, and then it divides in like two things. So either like the never gonna give you up check is right, or it's not the never gonna give you up flag. If it's the never gonna give you up flag, it's actually going further down. It's outputting never gonna let you down, and then it's gonna end the program, which is not useful to us. If we go further into this here, we actually know about the program that there's one more check at the end, and we know it's splitting in two ways. We know there's true and false, and we know that when it's false, it's gonna say access denied or something, and it's gonna go directly to the end, and here it's gonna say access granted and going to the end. So that's where we want to go. That's our challenge trophy thingy. I will just make like a bad trophy here. So that's where we need to go. So everything between there and there we still haven't figured out. We know some things though. So we know that there's a loop looping over something. We know there is some base 64 encoding ongoing, and we have found a base 64 string, and that is being compared. So we know all that. So now how can we fit this in here? Well, let's do some analysis. Looking at this code here, we should actually start from the bottom. So like I said, here's our base 64, and we're doing a compare and then splitting apart. We are also looking right here, we're loading something into memory and doing a lot of things on that, and then we're encoding it into base 64. So writing this down, we're gonna get our some input here, if we would see this as a function, and it's doing something, it's doing some B64 encode, and then it's doing a compare with this string there, and then it's splitting up in true and false. So looking at this part here, the most interesting part, because it's the only loop in the program, we know certain things. We know that it's moving something here into memory at this address R14D. So we can see, okay, wait, we're having a byte here, and that's kind of horrible to see. Okay, we see there's a byte here, and we're moving this byte here into this register. Then we're kind of splitting the paths. Here we're calling this function alloc rawvec reverse, and moving something out of this var 48h into this RSI register. we can also see that we have something going on down here. We see it's calling not R14B, which is kind of interesting. Then it's moving some things around, and it seems like it's checking RVP and RVX. RVX and RVP are basically two registers, so let's write some things down. Okay, we found that there's an out that there's a not thingy, so that is important. It's loading some byte, and we see, okay, RBX and RVP. Basically, if you have like a lot of assembly going on right here, the address of the beginning is RBX, and the address at the bottom is RBP. The further you move down, the further RBX moves down. And when it's actually here, it's saying, okay, I can go. So in this case, it seems like it's looping over something and checks if it's done with the input. And once it reached the end, it's actually gonna return to the base 64 encoding going on in the bottom. So we know this here is a function, fn. It takes in a byte, and it outputs not byte. So now we know what this does. This takes our string, so function of input, and that's gonna return B64, and it's doing the following. It's having a for loop, so for each character, in input, it's gonna do it's gonna take the byte of the character, so it's gonna take the byte of the character. It's then gonna do a not on that, and the binary not operator is usually a tilde key. So then it's gonna return the B64 of that here, it's gonna return the B64 of the changed input. And then down here it's gonna compare that. So if we write this program in Python, it should look something like the following. If we would be to implement this program again in Python, we should do the following. We retrieve some input, and we're gonna say flag here, and that's the first thing we do. We could do the never gonna give you up flag, but it's not really worth for what we need to do to retrieve the flag. So we have the flag input, and now what we need to do is we need to do our loop, and after the loop we want to encode it in base 64, and then we want to compare the base 64 to our string. So what we need for this stuff is two useful libraries. One is base 64 and one is NumPy, and we're gonna import this as np. So now we can say, okay, flag and bytes, actually input bytes, and we go for each character, in our input, we can do input bytes.append, and then we need to get the number of the character. And then to convert this to bytes, we can just use np uint8 and put this in there. So now what we need to do is we need to flip all the bits in that. So we could do this all in one line, but I'm just gonna do multiple things here. So printing our encrypted flag. We can do for byte in input bytes. We just do hey encrypted flag dot append b. And next thing we do is we're gonna take this and create our checking array. So our like flag to check is equal to base64 encode b64 encode, there we go, of our encrypted flag. But we actually need to do one thing. We need to do a byte array of that encrypted flag. So now we can say, okay, if flag to check equals our base64 hash. Then we're gonna print access granted. And if not, we're gonna say print access denied. We can also print some debug information here, just so we see, okay, flag to check. We can do a print here, and we can say, okay, encrypted flag, and we can do a print here, and we can say input bytes. So taking off this and running it, we get the following. We can input a flag, I'm just gonna say test, and we see for each character in this test flag, we see the bytes. Then we're gonna do our encryption, and we get this base64 hash, and it says access denied. So we now know how the program looks, and now we can write something that reverses this program. So to solve this, we just gotta go back up. Instead of going down, we're going back up. So we want this access granted case. So our input needs to match this. So it's very very likely that this is basically the flag that just went one time through this program. And we're gonna import our tools again. So base64 and import numpy snp, and we're gonna say, okay, our flag is this string. So first thing we could do is we can say, okay, the flag is base64 dot base64 decode flag. and we should have decoded the base64. Next thing we need to do is we need to go over each byte and actually flip the bits. So we can add one debug here, print flag. Next thing we can do is we do the flipping, so I'm gonna say flag bytes, do a list here, and we can actually just go over them. So for each byte in flag, we're gonna say flag bytes append B, and we still need to pass that to uint8 B. There we go. And we can print that out, flag bytes. So next thing we gotta do is we gotta convert these to characters. So our flag decrypted is a list. We want to run over this here, so for each byte in flag bytes, we want to do flag decrypted.append char of B. And we can print this out again. And now we can say print, and we can do a very nice print. We can say, okay, flag So if we run this program, Python 3 reverser, we see okay, we get our binary, then we get the bytes, we flip them, then we get the flag characters, and if we look here at our nicely formatted output, we get cracked my bad encryption. So that's basically all you gotta do. You can prettify this program if you want. It's not very complicated. We could like make one single thing out of it, but I'm not gonna do this, so it's like nicely readable. If you want to see a formatted version, put that in the comments, or put your version in the comments. Also share your way you solved this challenge in the Discord. And yeah, see you for the next challenge.